All right, Pythagorean theorem. Can't do these problems without the equation. A squared plus b squared equals c squared. C is always your hypotenuse. It's your longest side of your triangle. And I like to always draw this little diagram. If you make your little right angle into an arrow, it is always pointing at your hypotenuse. So if that helps you decide what you got going on there, do it. All right, so for number 11, I'm going to make A 28 and B 21. Go ahead and put this into the calculator. All is one. 28 squared plus 21 squared. And that gives me 1,225. Now remember, that's c squared. And in order to find c, we need to take the square root of both sides. So I'm going to go ahead down to new line. Remember, square root is right next to that ABC button. C is 35 centimeters, because that whole triangle is in centimeters. Okay, 12 and 13, you're looking for a side that is not the hypotenuse. So we're going to have to be a little more careful here. My C is going to be 17. A and B, remember, are interchangeable. I'm going to make A 8, and B is going to, X is going to be my B. So I have 8 squared plus B squared equals 17 squared. Students in my classes have been doing this a couple different ways. So I feel like if you're watching the video, it's probably because you need a little help. If you're needing help, I'd go ahead and we're going to treat this like a normal equation. I'm going to do 8 squared and get 64. I'm going to do 17 squared and get 289. And now we're just going to solve for b like normal. It's a positive 64, so to move it across the equal sign, we're going to subtract. 289 minus 64 is 225. And we're going to take the square root of both sides. Remember to take that square root. And we're going to get 15. Remember, our longest side should be across from our biggest angle. We should not get a number for B that is bigger than our hypotenuse. So that's a good little quick check to make sure your problem, your answer is reasonable. Okay, number 13. I'm going to make 8A again. X is B because 10 is our C. And you can write it as x squared if you would like. We are solving for x. On the last problem, I wrote it as b. It doesn't matter. Either way is fine. This one I can do mostly in my head. 8 squared is 64. Again, if you need to use a calculator for that, that's absolutely fine. 10 squared is 100. I'm going to subtract my 64 over. A 100 minus 64 is 36. Go ahead and put that into the calculator if you need to. It's going to give us x equals 6. Include units if there are units on your problem. That's a good thing to get into the habit of when you're working toward doing well in geometry next year. All right. Now our job is going to be to decide what's going on some word problems. So 14, 15 are two quick word problems for us. The thing that I always do with word problems in geometry is read it, draw a picture if no picture is given, and then I make sure I go back and read it again when I think I've got the answer to make sure I've answered it fully. So at Emmett's Evergreen Farm, the taller trees are braced by wires. A wire extends from 2 feet below the top of the tree to a stake in the ground. What is the tallest tree that can be braced with a 25-foot wire? So in this picture here that I have in color on the smartboard, that yellow is the wire. The yellow is the wire. And we have some values there. 25 is out here. That's going to be our C. 15 we have down across the bottom. I'll go ahead and make that A. And we need to solve for B. Now the thing we have to remember is that we are 2 feet away from the top of the tree. So we will have to add that 2 feet back at the end. I'm going to make myself a note. That way I don't get so excited about solving the problem that I go on without fully solving it. Remember, that brace, that wire, is going to be 2 feet below the top of the tree. So our tallest tree, we're going to, whatever value we find for B, we're going to add 2 feet to that, and that's going to be the height of the tree. Okay, so A is 15. We don't know B. We do know C. And we're going to do some calculator work here. 15 squared, well, we just did that. It was 225. 25 squared is 625. We're going to subtract over our 225. Ooh, this is a good one. 4, 0. And take the square root of both sides. So the distance from the base of the tree to where the wire is hitting, that is 20 feet. I have to add 2 feet to get that top of the tree, to get to the top of the tree. So the tallest tree that a 25-foot wire can be used to brace is a 22-foot tall tree. All right, last problem. Moesha is a college student and she needs to walk from her dorm room in Willis Hall, so that's right here, to her math class at Wells Hall. Normally she walks 500 meters east and 600 meters north along the sidewalks. Today she's running late and she decides to take a shortcut. So she's just walking through the grass and going. How many meters long is her shortcut? Well, here's our right angle, so our shortcut is going to be C. So in my calculator, I'm going to do 500 squared plus 600 squared. And I'm going to take the square root. Now be careful that you get the right number of zeros here. I need 4 zeros. 781.02. I went ahead and took that square root already. 781.02 meters. How much shorter is the shortcut than her usual route? So usually she goes 500 meters east and 600 meters north. So her usual route 500 plus 600, which is 1100 meters. To figure out how much shorter our new route is, we're going to subtract 781.02. Oops. $318.98 meters. So we tried to break these problems down for you so that you have the steps and it's kind of obvious to you that you need to do that extra step to find the shortest, how much shorter it is. But make sure you are, anytime you're doing a geometry problem, go back and reread really quickly and make sure that you answer the problem fully. All right, that's Pythagorean theorem.